Namaste guys, in this video we are going to learn how to make this actual engine mechanism in Solidworks. Okay, just for it is a conceptual engine mechanism. Who knows that one of my subscriber will make in reality. Love to see if anybody will make it. Okay, so before I start this tutorial, make sure that you check out my free courses for SolidWorks that I provide free of cost on YouTube, and my SolidWorks animation and motion analysis course if you want to learn motion analysis in deep details. It is on Udemy. Okay, so check it out. So let's start with the tutorial. So first I'm in assembly mode. Okay, first go here in design library, click on toolbox, click on NSI matrix, click on power transmission, click on gears. Okay, so I'm going to use some bevel gears. So import it. So you will get some properties here. Okay, so it's a number of teeth, gear number of teeth. So this gear has a 20 number of teeth. Okay, so if I increase it to, let's say, 30, as you can see teeth is increased. Okay, so in my case I will make it 30, and but this one I will increase it. Let's say it is near about, let's make it 20 first. It's because I have to pick a big value here. So 20 and make it something like 70. Okay, after that you see there is nothing pops out here, so we go down here and increase the mounting shaft distance diameter to 18. Okay, I guess I increase the value to 4. Let's make it 5 mm. This parameter is basically controls the shaft diameter, not this one. So sorry, so my bad. 100. As you can see this one increased, so but it is quite big, so let's make it decrease 50 mm. 50 mm is fine. Okay, so click OK. After that close this. Now first click on it and go to the toolcut. Not tool, not toolcut. Yeah, select this one, right click on it, click on show. Okay, after that right click on it and click on float so that we can drag it. Okay, drag this part as per our requirement. And after that what we are going to do is go to design library again and click on state bevel gear. Wait for some time, this will pop up. Okay, so if you are a mechanical engineer, I assume that you all know that a gear will mesh properly only and only if the module of the both the gear is same. If they are different, your gear will not mesh correctly. So if you watching the video carefully, then you will remember that this gear has a module of 1. So I'm changing it to module of 1, and number of teeth on this gear is 70, and number of teeth on pinion, it means this small gear, is 20. It is taking some time to do calculations, so okay, after that if you know correctly it is 20, so I don't need to change any value. And one more thing that you notice, it is quite big, so we need to reduce it. So go here and reduce it to value of 150. 150 is quite big as well. Let's see, okay, 150 is also big. Let's reduce it to value of let's say 60. It is fine for me, so click OK. It will take some time because it is a heavy task and I don't have a monster PC, so sorry for that. Now as you can see I have these two gears, so what I need to do is I need to do some meetings. So for doing that, I need this thing again. So go here, not this one, this one. Yeah, this one. Right click on it and click on show. After that, we need to do some matings. So click on here, uh, select this line, select the right plane, click OK, select this face, select the top plane, click OK, select this line, sorry, not face, we are going to select a line. Select this line and select the front plane, click OK, and move this gear a little bit upwards. Sorry, first close this, select this and move it upwards. It is not going. Don't worry about it. First, go to the mates. You see this point. Select this point and this point. I assume that you always know why I'm selecting the point and what is the significance of point. Just in case if you don't know, basically whenever you design this kind of uh, uh, helical gears, okay, bevel gears, sorry. So basically they are nothing just triangles, okay, cone basically. So here you can see these lines making a cone. Similarly, it makes a cone, and after that you will cut the teeth as per the requirements. Okay, so this is how they are designed. It is a quite complicated math thing, but I don't. Most of my users don't like to see math stuff, so I don't make it. Just in case if you like the math stuff, check out my other tutorial on Python coding, in which I have teach how to use basically various kind of engineering programs. Okay, so again, let's do the main focus on main topic. So circular, select this, and components to pattern this one. So I want four total, and make sure that you check out that teeth are correctly meshing. Here you can see these teeth are not. Two teeth are meshing, but two gear are meshing properly, but gears are not. So what we are going to do is right click on it and click on dissolve pattern. After that, move it little bit. Click on move components, move it, click OK, and select this point. Click OK, and we need to rotate it. Okay, now before I start rotating, I need to make sure that I don't move other places as well. So what I can do for that, I need to define something so that they will not move unwanted places. So what I can do for it, go to the mates, select the straight line, select the, let's see which, select the right plane, click OK. Similarly, select this face and select the line and make it parallel. Okay, when you do that, you will get the correct orientation. Now I need to rotate it, so let's do rotation part. Just rotate it so that they are at the correct place. So it is fine. So for this one it is done. So let's do same thing for other gears as well. Now I'm going to do this little quickly. uh, One more thing we can do is select this face and this face, make it concentric, click OK. Okay, for this gear we can also do use concentric mating. Select this face and this face, make it concentric, click OK. As you can see, I'm saving my time by using concentric mate. And just to know that lot of things I learned while doing. Okay, so doing practice will make you a better person. So right click on it and hide all these sketches because they create unexpected load on your computer. As you can see, my PC is getting slowed down due to that. Now I need to make let's see, crank and crank rod and piston. After that, our simply concept engine is ready. Okay, so let's create them. So click on here, click on new part. So first thing I have to select is a plane. So select the front plane, press Ctrl plus 8. So click on this. And while making this part, you need to remember some things, that make sure that your no external references is checked on. If don't, then you will not get the result that I'm doing. This is the most common ask and common mistake done by the beginners, and most I see most people ask this kind of question every day. So don't do this kind of thing. So make sure that you listen properly and do this step. Okay, sorry for being a rude teacher. After that, extrude it 5 mm. As you can see, the dimension it is 5 mm. So whatever I'm making, it is very small. Okay, and the best part is you can do 3D printing about this mechanism. If you have a 3D printer, if you are from a rich family, not a broke ass person like me, select this and this one and click OK. Now I've created one, and now I need a crank rod and a piston. After that we will use our something else and we will done. So let's make the crank rod. So for that, click on here, click on new part, select the front plane, press Ctrl plus 8, select this straight slot. Again, the height and length is up to you. Control Z. It's actually we made a small one. Just make it extrude for a bit. Then I will do other things. 5 mm is fine. Now select this, press Ctrl plus 8. After that, we will apply to use click on sketch, and we are going to cut some area from here. Okay, escape. Mirror entities. So select these lines, extrude cut through all. Click OK. Exit this mode and move this outward. Now go to the mates. Select this face and this face. Make it, and select this face and this face. Mate it. Now we need a one more thing that is called piston. Okay, so let's add it. First we need to create it piston. So click on here, click on new part, go upwards, select the front plane, press Ctrl plus 8, and we need to create a piston here. So First we need to create a cylinder, as we all know. Trim this line, go to the features, click on revolve boss base, select this line as a circle. Okay, I guess I have made it a lot bigger than the requirement, so cancel it. So first let's make it a small. And one more thing that I noticed sometimes, that many people ask me what are the dimensions of it. As you can see from our drawing, that even I don't know what are the dimensions. I just saw this mechanism on Pinterest and thought like, yeah, man, I can make it. So here I am making this drawing without knowing any kind of dimensions. I just saw some drawing on internet. I can make it. Okay, uh, practice. I have a lot of practice, so that's the reason I can make it. Okay, after that, let's make it a little bit bigger. Make it 20 mm. Go to the features, revolve workspace, click OK. Now we need to select this face, click on sketch, press Ctrl plus 8, and we need to make two corners. So 2.5, 1, 15, 7.5, escape, mirror entities, click OK, extrude it, click OK, select this face, click on sketch, press Ctrl plus 8, uh, 4 mm, 15 mm, and extrude cut. OK, exit the additional component mode. Now what we need to do is go to the mates, select this and this coincide. After that, go to the click OK. Click on here, click on view temporary axis and select this temporary axis, and I want to be this one, and go to the standard mates, and I want this to be parallel to it. Okay, so it doesn't move anything or do something funny. And select this part, go down here and go to the mates. You see they are combined, so right click on it, click on edit, okay, and click on lock rotation. So what does lock rotation do? If it rotates, it will also rotates. Okay, so this is what I want basically. Click OK. And one more thing, that I doesn't define the gear ratio in all these, so I need to define the gear ratio as well. So what can I do is go to the mechanical mates, click on gear, select this shaft and this one, and the gear ratio will be, this one is 20 and go here, and this one is 70. It will automatically pick it up. Okay, just in we will try rotate it. Yeah, it is working. Mm. Make sure that you don't mess with them badly as well. So click OK. Similarly, we need to apply these to all. Okay, so let's do it one by one. And one more thing, that we need these copies to other gear as well. So one thing what we can do is, we can drag. Okay, so before do dragging, let's make the gear mate. So go to the mate, mechanical, uh, gear 20, 70. Click OK. Again select this one, select this one, gear 20, 70. Select this one, select this one, gear 70, 20. Click OK. Let's see once how does it look at rotation. So rotate. As you can see, if I try to rotate it, I'm getting the desired rotation. Now, one thing that is left is if we need these parts. So one way to do is that I create a subassembly of these two parts and use it, or I will just simply try use the mirror command. But if I use circular pattern command, it will all do the in same matter, and I don't like it. Okay, one thing you can do is, if you are a lazy guy, select this one and select these parts and increase the number of instances. You can do this step as well, but somehow I don't like it. I don't know why. So if I try to rotate it, yeah, I don't know why. What's I don't know what's happened. If you don't know that Solidworks has a lot of bugs, so press Control Z again, Control, or just simply go down here, right click on it, and click on delete. Yes. So I don't know. That might be a bug in Solidworks, that it doesn't resolve properly. Why does it happen? I don't understand sometimes. So what I'm going to do is, I will import all these parts. Not going to import this, drag and make again the mating. So let's see how do I do it. So by pressing Control, drag it. By pressing Control, right click on your mouse, drag it. By pressing Control, right click on your mouse, drag it. So this is one. I need three more. So what I can do is Control and drag it. So go to here, select this one and this one, and make sure that you use lock rotation. Click OK. Select this face and this face. Click OK. as you can see, this one is moving forward, backward, and I personally don't like it. I don't know why it's going. Okay, I know why it's happening. Let's me fix this issue. So select this gear, go here and go here, select this, click on show, select this gear as well, and go here, right click, show. Now go to the mates, select this point, select this point, uh, why it's over defining it. Select this gear, and let's see what kind of mates we have. Okay, so right click on it and delete this one, and go to the mates. I need to select the point. Okay, click OK, that's all, and go here and hide sketches. I will call them later onwards when if I need it. One more thing, you can see that they are moving independently and I don't like it. So what I can do for it, go to the mates, select this axis, zoom out, select the front plane, click OK. Okay, now what we can do is go here, select this face. Now I will wrap up quickly. I don't want to waste any more time of yours, neither mine. As you can see, my computer is lagging. Number of meshes quite increased. It's a heavy project for my PC. Right click on it. Uh, Select the coincide. Click OK. Now we need to do for two holes. For those two, so go here. Select this one, go to its mates, right click on it, edit feature, and click on lock rotation. Click OK. Click OK. Hide the view temporary axis. So now it's time to see the animation of it. So go to the motion study, motor, select this. Instead of, let's say, 30 rpm is okay, and increase the frame rate to 30. Click OK and click on calculate. Don't worry, it is just do calculation. That is the reason you see it's lagging or sluggish. Once the simulation is done, you will see how does it work. Now here you can see this one doesn't work properly. So what is the reason? The reason is that I doesn't define the mates like with plane. That is the reason it is showing me the error, like this kind of animation. So go to the models. So first thing I have to do is click on here, click on view temporary axis. After that, select this temporary axis, go to the mates, select a plane, right plane, click OK, and again go to the motion study. Yes, I have modified it. And if you want to learn about animation, how to do animation, what are the principles, and how to do calculations with motion analysis, check out my course link in description. You will learn a lot of things from that. So here you can see now it is working properly. So hide the library access, move it downward. So click on play. So as you can see, so this is how a axial engine works. So right click on it, disable the orientation so that we can view the perfect view. So yeah, this is the perfect one. So here you can see the animation. You can see gear meshing. So yeah, that's for all in this video. So I hope you learned something from this video. If you have any kind of doubts and queries, feel free to ask. And this project file is free of cost, available on my GrabCAD, so you can download from there if you want it. So thanks for watching, and if anybody want to support this channel, I highly recommend please buy my Udemy course because it helps me, it support me very helpful. So I will be thankful if anybody support me. So thanks for watching and have a great day. Namaste.